let's look at place value again, but this time using decimals. But first I'll revise what we've done with you before on place value. So I've written a number here. If you use commas, they go 3 from the end. This is a whole number, integer. 5,638,453. Revise how you put your hats on. Units, tens, hundreds. Then we have thousands, or units of thousands. Tens of thousands and hundreds of thousands. Then we have millions. If we kept going, it would be tens of millions, and then it would be hundreds of millions. So those are the places we talked about before. This number we say 5 million, that's a millions comma. 638,000, that's a thousands comma, 453. But now we're going to look at some more hats and caps we need to know, some more place value knowledge we need, and that's for decimals. So this is what we call our decimal hats. We've got 1/10, that's actually a fraction because decimals are fractions. They're just a different looking version of fractions.
They are representing parts of a whole number. So anything that's less than a whole number is either represented as a decimal, as a fraction, or as a percentage.
So anything after the point is a part of a number, like Mr Blom said, a part of a whole number. It's just a bit. These are much less significant columns. A very significant digit is over here, this 5 in the millions column. 5 million. It's a hugely significant digit, the most significant digit in this number. Something like 3 units, that's 3 whole ones. That's the least significant digit so far. But the decimal places are smaller than this. So if I have a number in the 10th, like a 1, that is worth 1/10. 2 is worth 2/100ths, and 5 is worth 5/1000ths. I'll explain the sizes of these numbers in a minute, because these are small. Decimals are small little bits. Even though 1/1000 looks quite big, it's actually, this 5 here is the least significant digit on the page because it's only worth 5/1000ths, which are very small. So I'll try and explain this in another way. If you have one piece of paper, you've got one whole, clean, clear piece of A4 paper. That is one piece of paper. But if I rip that piece of paper up into 10 bits, 10 equal bits, I'd have no whole piece of paper anymore. I'd just have 10 scraps. If I threw away 9 of the scraps, I'd have 1 left. So that is 1/10 of a piece of paper. It's smaller than a whole piece of paper because I've only got 1/10 of it. If I ripped a piece of paper up into 100 bits, 100 equal bits, I threw 99 of them away and had 1 left, I'd have 1/100th of a piece of paper. That's a very small amount of a piece of paper.
In order to get to that one piece of paper, you need to have 99 more of that same little piece.
Yeah. If I ripped a piece of paper up into 1,000 bits and I threw away 999 of them, 1,000 equal bits, threw away 999 of them, I'd have 1/1000th of a piece of A4 paper. That would be the tiniest little scrap of a piece of paper. That's why thousandths with the TH sound on the end are really small. In fact, anything with the TH sound on the end, tenths, hundredths and thousandths are really small bits, decimal bits. So there are place values, 1/10, 1/100th, even smaller, and the smallest one you'll need is 1/1000th. They do carry on. You can get 1/10,000th, 100,000th, 1/1,000,000th if you've smashed something up into 1,000,000 pieces. Some teachers might mark tenths with a little t, just so you know, hundredths with a little h, and thousandths with a little th. Notice how they can't use a capital T because we already used it for tens, and you've got to know the difference. So they use a little t for tenths. The next thing to talk about in terms of place value with decimals, let's say we have number 6. Say we have 6 whole pieces of paper. 6 is the same as 6 point nothing. 6 is the same as 6.0, so we can even write 6 equals 6.0. Those numbers don't look exactly the same, but they are exactly the same. It's 6 and nothing else. So one thing I want you to answer is if I say something like, here's a number 254. Where does a decimal point go in this number? And what I'd always want children to answer is at the end. So if there's no decimal point in the number, it goes at the end, because 254 is the same as 254.0. You can see the units and then the decimal point, and that's actually the 10th column, isn't it?
Mm-hmm.
But it's worthless. This 0 here is worthless. 254 is the same as 254.0.
The question I always ask when children get confused with knowing that you can just put numbers after the decimal is, does the value of the number change at all? So obviously if you have the number 6 and you put a 0 next to 6.
Oh, that's naughty.
Okay. And then you put a 6 below, a decimal point and a 0, and you put a 6 below again. So what I've shown you here is that you've got 60, which if we add that 0, it changes the value of what that 6 is. That 6 now becomes a 10. If you've got 6.0, that 6 is a unit. And if you just write 6 itself, the number 6 retains its value of being a unit.
So we take a number like 68. 68 is the same as 68.0. I'm not using the hats, they're not lined up in above, this is a different example. So 68 is the same as 68.0. It's also the same as 68.00. It's the same as 68.000 because it's still 68 point nothing. So if you have the number 68, and Mr Blom will show you an example with money in a little while. If you have the number 68, sometimes you need to put a decimal point on in order to do some workings with it. So if there's no decimal point on 68, where does it go? At the end. 68.0 or 68.00. 68.000.
A way which I know is quite a popular way to teach understanding of decimals is to incorporate money into it. So we all know that there is a unit of measure that is worth less than a pound, and that is a pence. Now, in everyday life, what we would do is we'll count everything in pounds. So if I said I had a drink for £1.50, if I was looking at this on my little place value area over here, my £1 represents my 1 whole pound. And then I've got 50 pence. So I have 50 of a whole pound, which is basically half of a whole pound. But that 50 is represented, let's move this up over here, the 50 is represented like this. £1, 50 pence. 5 tens of what makes a whole unit. But what happens if I have something like 30 pence? Well, I'd have 3 tens of a whole unit, but would I have anything in the unit? No, and you always have to identify with some value in the units column, don't you? You can't just write point something, you have to write a 0. How about £25 64 pence? Well, if I wrote £25 64 pence, I have £25, 5 pounds. How many pence did I say? 64, did I?
I can't remember now.
So I got 64, so I got 4 hundredths and 6 tenths of that amount. In order to get to a whole pound, I would need to, let's say, add 6 there and then add another 3 tens, so it would be 36 pence in order to make another whole pound.
How would you do the decimals on £47, Mr Blom? Where would the decimal go there?
Right, so always show your units of measure. 47 whole numbers, which is 7 units and 7 units and 4 tens. When you write pounds, you actually have to write it to what we call 2 decimal places. Now, 2 decimal places is 2 places down the place value, your tens and your hundreds. Now, what happens, if you don't have any value in the decimal area, as in you don't have any pence? You just put your placeholders in. What are placeholders? Our placeholders are 0. Does it change the value of what £47 is? No. It just shows us that we have £47 and no pence whatsoever.